In section 7.4, we will graph quadratics. For part A, we're going to look at the features of a parabola, one of which is the axis of symmetry. The definition for axis of symmetry is a vertical line that divides the parabola into congruent halves. Because this is a vertical line, it's always going to be written as x equals a number. So in this example right here, because this crosses at 3 on the x-axis, this would be x equals 3. And again, you can see that the parabola is symmetrical on each side. The vertex is the lowest minimum or highest, which would be the maximum, point of a parabola. So in this graph that's provided here, our vertex would be a minimum value. If the parabola was pointing down, the highest point would be our vertex, and that would be a maximum value. The x-intercepts are the points at which the parabola crosses the x-axis. So in this case, those values would be at +2 and +4, or we could consider those 2, 0 and 4, 0. So for example 1, you're going to identify each of the following. AOS for axis of symmetry, and remember that because it's a line, it's not a single point, we do want to write that as x equals a number. So you're going to figure out where the axis of symmetry is going to be and what number it's crossing on the x-axis. That's going to be your answer here. For the vertex, you're either going to be looking at the highest point or the lowest point in each of these graphs. And then for our x-intercepts, again, that's where it's crossing over the x-axis. So this would be a good time to pause the video and fill in those answers. And the answer for the axis of symmetry here is going to be x is equal to 1. Because again, it's what's going to split the parabola in half and make it symmetrical on each side. And because that's passing through at 1, that's why our equation is x equals 1. The vertex, again, is this high point here, and that ordered pair is at 1, 9. The x-intercepts, again, are where they cross. So we have 2 points where it's crossing here, and that's at -2, and it's at +4. So I'm going to write these as -2, 0 and +4, 0. For number 2, we do the same thing. So again, if you haven't filled that one in yet, this would be a good time to pause the video and fill those 3 in. For the axis of symmetry, that's going to be x equals -2. The vertex is going to be -2, -1 in this case, and our x-intercepts are going to be at -3 and -1. Do the same thing for 3 and 4. So again, pause the video here, fill in your answers to 3 and 4, and then you'll compare those to mine. For number 3, the axis of symmetry is going to be x equals -5. The vertex is going to be a low point in this case. That's going to be at -5, -9. And our x-intercepts are going to be at -8 and -2. So we can write those as -2, 0 and -8, 0. For number 4, our axis of symmetry is going to be x equals 1. Our vertex is a high point in the graph, so that's at 1, 9. Our x-intercepts here are going to be at -2 and +4. So we write that as -2, 0 and 4, 0. Okay, moving on to this type, here's where we're going to actually come up with the graph. So in the previous examples, you were given the graphs and we just identified a few things based on the graph. Now we're looking at the equation, and from that equation, we need to come up with the axis of symmetry, the vertex, and the x-intercepts. We're also going to need to have a total of 5 points here, so it'll be 2 additional points that we're going to come up with. We'll plot everything and we'll connect. So when we're doing the axis of symmetry, you need the formula for that, and this is something you'll need to memorize. That formula is x is equal to -b divided by 2a. Now you want to remember that this is in the form ax squared plus bx plus c. So we need to do the opposite. I mean, I don't like to think of this as -b. I think of it as the opposite of b. So that +14 is going to be a -14 divided by 2 times 1. So we'll simplify that, which gives us -7. So we're going to have our axis of symmetry is going to be x equals -7. So I'll go ahead and plot that accordingly. Now from here, when we go to find the vertex, this will be the x value for the vertex. And so if you actually look back through the previous few examples, what you would notice is that the x value in the vertex is always going to match up with the axis of symmetry. So here I can say the x value is -7. When I'm finding the vertex, then I'm going to take a -7 and I'm going to plug it in for both of these x's and solve for y. And you can use a calculator to do that. And I would encourage you to use a graphing calculator and to type all of this in at the same time. So we want to make sure that -7 is in parentheses with the squared on the outside, plus 14 times -7 plus 48. When you type all that in, you should get -1. So I'm going to put that in the middle of my XY chart that I have right here. And now I can plot that on my graph at -7, -1. Now from here to find the x-intercepts, we're going to go back to something we did in one of our previous lessons. I believe that was in lesson 7.1. We're going to take our original equation here and we're going to factor it. So I'm going to take that and it's going to factor to x plus 6 and x plus 8. Now if I set each of my factors equal to 0, I'm going to get -6 and -8 as my x-intercepts. So I can go ahead and put those in my XY chart and plot them accordingly. Then from there, I'm going to want to find 2 additional values. In Delta Math, they're going to expect you to have a total of 5. So I'm going to want to look at one value to the left and one value to the right of the numbers that I have so far. So that's going to tell me to look at -9 and at -5. So I'll take -9 and I'll plug it in for both of these x's. The answer you should then get would be 3. Then you're going to take -5 and you're going to plug that in for both. Now, because I am expecting symmetry here, I would be expecting that it's going to be 3, but it's good to double check that. And I do get 3. So when I plot those, everything is symmetrical and I can go ahead and create the parabola. So again, I would pause the video at this point, see what things you can come up with before watching the explanation. So again, here I would start with the axis of symmetry. The axis of symmetry formula is the opposite of b divided by 2 times a. So I'm going to take the opposite of -6, and that's +6, divided by 2 times -1. That's going to give me -3. So then I'll take that and plot. Now from there, again, that's the x value for the vertex. So I can take a -3 and plug it in for both of these x's and get my y value. Be careful here with these negatives. So I've got a negative in front of this x. That's going to stay on the outside, but then -3 needs to go on the inside of the parentheses. We're squaring that. Then -6 times -3 minus 8. When you simplify all that, and again, let your calculator do the work for you, or just make sure you realize you have to do -3 squared and get +9 before we then consider this negative. So that makes this turn into a -9. This is going to be +18 and then -8. And as you combine that, we should get 1. So I can go ahead and put -3, 1 in for the vertex and plot that accordingly. Now from here, when I'm looking for my x-intercepts, I'm going to have to do some factoring. The first thing that I would do here is get rid of this negative in front. Now if I want to get rid of this negative, I'm GCFing a negative out of everything, which means everything's going to change signs. So when I take out that negative, I was left with x squared plus 6x plus 8. And then from there, when I go to factor, my signs were both going to be positive. 2 numbers that multiply to give me 8 and add to give me 6. These were my factors. Then if I set each of these factors equal to 0, I get -2 and -4. Those are my x-intercepts. So I can go ahead and put those into the chart and plot them. And then just like the last one, I need 5 total values. So I already have 3. I'm going to want to know what's going on this side and what's going on that side. So the numbers I'll be looking at there would be -5 and then -1. And again, I'm going to take -5, I'm going to plug it in both of those positions, and I should get -3. Then I'm going to take -1 and plug them into both of those positions, and again, I should get -3. We'll plot both of those, connect, and that's going to be our answer. Okay, taking a look at this one, again, you should pause the video, try the problem on your own. And if you're getting stuck at a certain point, you can play some of it and then again pause. So once again, the first thing I'm going to look at is the axis of symmetry, and that's going to be the opposite of b divided by 2a. So if I do the opposite of -4, that's +4 divided by 2 times -1. That gives me 4 divided by -2, which is -2. So that's my x value for the vertex. Then I can take that -2 and plug it in for both of these x's. The work would look like I have here in green. So when I plug that -2 into both of those positions, my answer is 9. So that means that my ordered pair for the vertex is -2, 9. I'll go ahead and plot that then. Now from here with the x-intercepts, again, we want to start by GCFing a negative out. That's going to leave me with negative times the quantity x squared plus 4x minus 5. If I factor from there, I get x plus 5 and x minus 1. Setting each of those equal to 0 gives me solutions at -5 and +1. Now you'll notice that I didn't put them right on the outsides here, and that's because there is some values between -2 and -5, and as well as -2 and 1. So I'm going to go ahead and plot those, and then I want to know what's going on in between these values. So I could either choose to try, say, a 0 or a -1, or I could do a -3 or a -4. The values that I chose were -3 and -1. You do want to pick ones that are equally distant from the axis of symmetry. That's always going to be your best option. So either the two that I picked, or maybe you would pick 0 and -4 would have been good options. When you plot those, it should look like this and connect, and that should be your final graph. Again, try number 3 on your own. And when we're looking at the axis of symmetry here, I've got the opposite of b divided by 2a. In this case, it's going to be the opposite of -2, which makes that +2 divided by 2 times 1. That's going to give me 1, and that means that I can go ahead and plot that axis of symmetry, that vertical line at 1. From there, that's the x value for my vertex. So I'll go ahead and plug a 1 in for both of these x's here, which is going to give me an answer of -4. So I can plot 1, -4. And then from there, I'm going to go ahead and find the x-intercepts. So with that, I'm factoring x squared minus 2x minus 3. The factors are x minus 3 and x plus 1, which would give us solutions at 3 and -1. So we'll go ahead and plot those accordingly. Once again, I'm not putting them right on the outsides, and it's okay if these don't end up in the correct order. You know, if you did get in the habit of just always putting those there, just know that your values might not be in the correct order when they're in the table here. I chose to separate mine. There is a value in between these, and there's a value in between those, and those are the ones that I'm going to plug in to get my 5 total points. So in between these, I would want to plug in 0, and in between these, I'm going to want to plug in 2. So if I plug in 0 into this expression, I'm going to get -3. So 0, -3 is one of the ordered pairs that I will plot. Then if I'm plugging in 2, that's also going to give me -3. So again, I plot both of those. That's what my parabola should look like, and that will be my answer. Okay, and for part C, we're looking at a different way to represent these different quadratics, and this is the vertex form. And so we have this setup right here. We would have like either y is equal to this expression, or in the case of what we're going to see in lesson 7.5, we might see y is greater than or equal to, or less than or equal to. So we'll talk about all of that in section 7.5. So first of all, we want to note that if our value for a is greater than 0, the graph is going to open up. So our vertex would be a low point in the graph, and it would open up. If our value for a is less than 0, so it's negative, it's going to open down. And if you've looked back through all the examples that we've done so far today, you would see that happening throughout all of the examples. Our vertex is going to be h, k. So what you're going to want to notice here is that since this is -h here, but then +h here, you are going to switch the sign of this one. You're not going to switch the sign of this one. So keep that in mind when we're actually doing some of these problems. So in this example here, this one is going to open because it's negative out in front of that expression. It opens down. Then, like I mentioned a minute ago, when we're coming up with the vertex, we have to take the opposite of this value. So I take that +2, it's going to be -2, and I leave that 4 alone. So this is -2, 4. Then I'm going to go ahead and plot that at -2, 4. Now from there, there's a few different things you could do. You could technically solve this and try to find the x-intercepts. What I'm going to encourage you to do instead is let's pick 2 values to the left and 2 values to the right of our vertex or axis of symmetry. So on the right, that's going to put me at -1. If I plug -1 into my expression here, -1 plus 2 is 1, 1 squared is 1, -2 times 1 is -2, and then if I combine that with a +4, I get +2. So I can go ahead and plot that at -1, 2. Then I can go ahead and do the other side because I'm again expecting symmetry here. So I think that if I plug in a -3, I better also get that too. And that's what happens. From there, I might plug in 0 on this side and then eventually -4 on this side. If I plug a 0 in, 0 plus 2 is 2, 2 squared is 4, -2 times 4 is going to give me -8, and -8 plus 4 is -4. So I'm going to get 0, -4 for that value. When I try for -4, I should get the exact same number, and then again I can plot that parabola. So we're doing the same thing we were doing in the previous examples, they're just presented in a different form, so the order of which we do things changes just a little bit. All right, this would be a good time to pause the video, try this one on your own, and we will take a look at it together in a couple of minutes. This one is going to open up, again, because our a value is positive. From there, our vertex, we take the opposite of -1, that's going to be +1, and then the 2 is going to stay 2. So I'm going to go ahead and put that in my XY chart, and I'll plot that accordingly. Now that tells me that the axis of symmetry is right in line with that. So what I'm going to do is pick 2 values on either side of that axis of symmetry. So one value that I could pick is at 0. So if I plug 0 into my expression for x, 0 minus 1 is going to be -1. -1 squared is 1. 3 times 1 is 3, and 3 plus 2 is 5, and that's where we get 0, 5. So I can plot that. Now that means that if I plot this number right here, which is 2, I'm expecting that I'm also going to get 5 there. And if I test that again, I get 1, which squared is going to still be 1. 3 times 1 is 3, plus 2 is 5. So 2, 5 is going to work out. Next, I'm going to want to do 2 values on the outside of those ones. So I might try -1, and when I plugged in -1, this is -2, squared that, I get +4. 4 times 3 is 12, plus 2, that's where I got the 14 from. And when I try to plot -1, 14, it's going to end up off my chart here. And so I'm actually not going to bother plotting that. If you're doing this in a program like Delta Math, they should adjust the x and y axes, and I would expect that you could plot those values still. In this particular one, we wouldn't be able to plot. We could estimate, roughly where they would be, but it's not necessary for us to plot these. Same thing that happens at 3, 14, and we wouldn't be able to plot those. So that's going to be our parabola for number 1. Go ahead and pause this and try number 2. This one is going to open down. Our vertex is going to be -4, -1. So we can go ahead and plot that. From there, you want to picture like what this is going to look like. I know it's going to point down. And so I want to try some values on either side. One that I might try is at -5. Now, if I plug -5 in here, I've got -1. -1 squared is 1. Then I still have this negative in front of it. So this is -1 minus 1, which is -2. And so I get -5, -2. So then on the other side, that would be plugging in a -3. And I'm expecting it to get the same answer, but again, you should test that and make sure that you are in fact getting -3, -2. So we'll go ahead and plot both of those. And then from there, we can do the outside of those two. So I would be looking at, on this side, it's -2, and on this side, it's -6. So I can go ahead and plot those, and what I should get as answers for the y values for each of those would be at -5. Those are on the coordinate plane that we're given, so we can go ahead and plot those and connect. The last part that we're going to look at with graphing quadratics is going to be some word problems that involve quadratics. So pause the video, read through the problem, and try to figure out what the process is going to be behind this. Now, when we're looking at this one, so we want to kind of picture this, and obviously we're talking about a quadratic here, which means we're looking at a parabola. Another thing to note here is that there's a negative out in front here, and that means that this one is going to open down. So we're kind of picture that it looks like this. So we have this 80-foot cliff. The initial velocity is 120 feet per second. And we're trying to figure out the maximum height of the rocket. So we're trying to solve for h here eventually. So what we want to think about here is, where does that maximum occur? Well, that maximum is going to occur at the vertex. And what we're normally used to is figuring out the x value. In this case would be our t. So when we're looking to figure out what t would be at that maximum value, we're looking at the axis of symmetry. So what I'm going to do is use that formula for axis of symmetry. I'll do the opposite of positive 120, which is negative 120, divided by 2 times negative 16. That's going to give me 3.75, and I would round if I needed to. Now, from here, if they were just looking for when is it going to reach its maximum height, we would be done and we would say our answer is 3.75. However, this one is looking for the height. And so our height is our y value when we're looking at the parabola. So our y value in this case is an h. And so to figure out what h is at that particular point, we need to take 3.75 and plug it back in for both of these t's. So when we do that with the calculator, we should get 305. So that's why our answer for this one is going to be 305 feet. Now this one is slightly different than what we saw in the previous example. The previous example is going to be more in line with what you can expect on a final exam in this course. However, this type is more similar to the types that you're going to see in Delta Math. With this one, we're not trying to figure out what the profit would be. So we're not trying to solve for y, and that's what we were doing in the previous example. We were solving for that value that's over on the left, which was an h value. Here we're just trying to find our x value, which would be the selling price for the widget, when it's going to make the maximum profit. So we're still going to be looking at the vertex here, but we only care about the x value in this because we're not trying to figure out what the profit is. So in this case, again, I'm going to do the opposite of 72, so negative 72 divided by 2 times negative 1. And that is going to give me 36 cents, and that's my final answer. So again, if we were trying to figure out what the profit is, that's when I would then take that 36 cents, plug it back in for all my x's, and that would give me my y value. For number 2, when I'm looking at this one, it's the same type of question here. We're trying to find not the height, which is y, we're trying to find at what time does that reach its max. So again, it's going to reach its max, if you're thinking about the parabola, at the axis of symmetry. And we're only going to look at the x value here. So again, I'll do the opposite of positive 197, which is negative 197, divided by 2 times negative 16. That is going to give me 6.16 seconds. So again, if I was looking for what is that height, I would take that 6.16 and plug it back in. But in this case, I am finished at that point. So pause the video and read through and try to solve number 3. So with this one, again, I'm looking for just x. So I'm going to do the opposite of 700, so negative 700 divided by 2 times a, which is negative 9. That gives me 39 cents, and that is going to be my final answer. Again, if I wanted the profit, I would take 39 and plug it back in for my x's there, and that would be my answer. So now go ahead and complete the Delta Math assignments that are associated with the second part of section 7.4.